My name is Fred. I work on Keybase and the Keybase File System. So what is the Keybase File System? It's a distributed file system with end-to-end encryption and a global namespace. Later on, when I talk about the tech behind KBFS, I'll go over what those words mean or how we use them. But for now, I'll start with how to use KBFS. I'll also like to mention that the KBFS client code is open source, and it works on Windows, Mac, and Linux, all the major desktop platforms with support for mobile planned. Right, so this is my own encrypted folder. That is a back color I use, but it says Keybase private Akalin, the path. So anything I put in that path is encrypted only for me. So no one else will be able to read it, including Keybase. But let's say that I wanted to share files with you. Now I have the folder Keybase private your name, Akalin. So any file in that folder, assuming you have a Keybase account, means that will be only readable and writable by either you or I. And if I only know you via Twitter, and I prefer to assert that, then there's also the path Keybase private Akalin, your Twitter name at Twitter. And then if you access that path, it automatically points to the second path with your Keybase account.
So this works a lot like Dropbox, essentially. You've got a magical folder that you can see in your file system with your stuff in it. But it's better because you also have a magical folder with that is shared with somebody else. And because of Keybase's distributed trust, you know that person is that person, or at least you know that person is the Twitter user that uses that account or whatever.
And if you wanted to add someone to that folder?
You create a new folder with the three of you.
Okay.
Right, and then you move the files or you copy them or you do whatever.
Okay.
Right. Right, so these folders are encrypted using the public device keys. And since with Keybase, you can do so automatically. There's no negotiation, there's no problem of like, hey, I need your PGP key or anything. It happens automatically. And even if you're not signed up for Keybase, if I put a file in the folder Keybase private Akalin, your Twitter name at Twitter, Keybase will encrypt it for me, and then when you sign up for Keybase, it'll automatically re-encrypt those files so that you can read it, and only you can read it. Or rather, not Keybase, but my client does, because Keybase can't read the file. So my client, one of my computers has to be awake, and then it'll rekey for you, and then send that, and then you'll be able to read those files. And here's an example of what we want to avoid. So if you're talking with someone on Twitter and you want to send them a file, you kind of have to do this like dance of, hey, do you have Dropbox? Let me send you my email. Oh, like DM me your email address, but you have to follow someone, or you have to be followed by someone to be able to DM them or something. Yeah. And so there's this little dance of, hey, I'll have to email you when I get off work. With Keybase, if you're talking with someone on Twitter or Reddit, you just drop a file in the folder and say, hey, look in our shared folder, and then the file will be there. And even if you haven't signed up with Keybase, once you sign up, the file will be there.
And you can publicly announce that folder name, and only that person can access that folder.
Right.
And they have to have what on their end for that to happen?
They have to have what?
Like on the client side, on their side, they don't need Keybase FS?
No, they do. Once they sign up with Keybase, then they'll be able to access that file.
So what he's asking, I think, is you would need the Keybase client, the other person to access it.
Probably.
Just like you needed.
You should be able to see it if you install the Keybase package on your device, actually. on the Mac or on Windows, right?
Yeah.
Right. Okay. So there's no web way?
There's no web way for private folders, yes.
Okay.
We've thought about it, but I think right now it would be difficult to do so in a secure way, and that would be the point of.
Right.
Yeah, the difference is just that whether they've got it or not, you know that they're going to be the one who can get it. And because, and also because one of the things that the Keybase system, the underlying Keybase system does is basically, and you said this too, like, you know, you're using all your different social media accounts, but there's also a time element to it. And essentially, if they've signed up way back when, you kind of know that that's still the same person.
Right.
And so you can know that, you know, even though W.C. Preston is not on Keybase yet, I shared a file with you. And whenever you sign up, when you're ready, you're going to get that file.
Okay, maybe I'm stupid. It's possible. If you put that out publicly, why can't someone else sign up as him and get the file? Am I totally missing something here?
Because they can't get into his Twitter account.
Okay, but you're just saying right here you don't need to use DMs anymore.
His Twitter account is verified with Keybase.
And it's not just Twitter. It could be almost anything.
Like, or something else.
You know, and
Reddit.
You know, so you could use, you know.
You have two parts. So you sign up on Keybase and you create an account. So your account is going to be Scott Lowe, okay? But for your Twitter identity to be validated, you would have to post the public key that you have on Twitter, and then it links the things together.
Got it.
Yeah.
Makes sense now.
And that's kind of what happens is you kind of build, it's like a stair step kind of thing where you're kind of building up these links to all these different sites. And when you do that, it validates that you're you, and then other people follow you, and then they're validating that at this time, that was you, and so on, until we have a kind of a solid web of trust.
Go back to his
I used that word.
Yeah.
How do I not know? So I've shared a file with Scott. Scott's not on Keybase yet, right? But I know his Twitter ID. How do I not know? How does Keybase know that someone didn't hack his Twitter account between now and then?
And somebody could. They could hack his Twitter account, and then they could sign up for Keybase, and they could post his public key and validate the Twitter account, even though they've got access to it. That is something that could happen.
But that's the value of having more than one validation source within Keybase, right? So, like, I'm using my Reddit, my Twitter, my GitHub.
Right.
I'm using DNS records to validate it.
Right.
You know, the more you add, the less likely it is, unless
that's a good point.
The same password for all services, right? Which nobody.
So, like, I've got it in my blog.
You know, yeah.
Right.
And so, you know, and in my GitHub and so on. So it's like, it's hard
Right,
to.
but that means I'm pretty sure I know who you are because you're already set up. I was going more.
Right.
Yeah.
And
You're absolutely right about that.
Yeah, the first step is, if someone compromises you between when I send you the file and when you sign up for Keybase, then, you know, we can't really protect against that, but it's no worse than what can happen. Like if someone hacks your Twitter account and you try to send them a file in some other way,
it's the same problem.
It's the same problem.
Yeah.
Well, like you could, for example, you could say this person needs to have this level of trust rather than a single Twitter account, because you're saying you can do authentication via several ones. Like it would be nice if I could say, well, he needs to be authenticated via 3 methods.
Yeah, you actually can do that. If you drop a file in a folder with with 3 assertions,
so Twitter or so and so.
Yeah.
That's cool. Yeah.
So, when you
Wow, I didn't know you could do that. That's cool.
Yeah.
when you send someone a file, where does the file stay?
What?
When you send someone a file, where does the file stay?
It stays on our server or our servers, or the encrypted version stays on our server.
But they don't hold the key, so they can never decrypt it.
Yeah.
Right, it just sounds like they need a massive amount of storage space as more people start to use this. I mean,
Yeah.
So far, the limit is 10 gigabytes.
What?
The limit as of now is 10 gigs.
10 gigabytes
per
yes,
user.
Per user, yeah.
So no porn.
Cool. Any more questions?
I don't know if it makes sense to speak about it now, but maybe kind of putting the relationship between the validity of the keys and what you do with the keychain, with or you kind of certify that and make sure that it's inviolable in, how to say, that someone cannot tamper, let's say, the identities on your servers?
Sure, yeah. I have a slide for that later, but well, I'll definitely go over that.
Okay, cool.
Okay. Right. So in addition to private folders, we also have public folders. So Keybase public Akalin, any file that I drop in there, well, it's public, so everyone can read it, but it's also signed by me. So if you access it on Keybase, on the KBFS, you know that that file can only have been written by me. If someone tries to tamper with it, or if Keybase tries to lie to you, then the signatures will verify, and you just won't be able to read that file.
So the first one and the second one are actually the same folder?
Yes, the first one and the second one, yeah. F-A-K-A-L-I-N at Twitter is me, so it'll resolve to the first one. So someone can, if someone only knows me via Twitter, they can use that assertion, and then it'll point to the right Keybase account.
But not just the right account, but that same. I'm saying the folder on the top and the folder on the bottom.
Yeah.
Different than your first example. Those two are you saying they're pointing to the same public folder?
Yes.
Okay.
In the first example, they should be the same too.
Like, I'm assuming the top one and the second one are different folders.
Yeah, those are two different folders.
Okay, but in this one, those are the same folder.
Right. Yeah, you can also have public folders with multiple people, but that you can theoretically, but it's a little confusing to think about. Like, what does it mean? It actually means that any file in there can be signed by either me or the other person, which may or may not be what you actually want. So I just had, my example only had one person's public folder because that's a little easier.
How do I access this on my client? So how do I access your public folder on my client?
You go to this path. It's like a global path, so you can use the Finder, the terminal.
Okay.
Assuming that you have the Keybase client installed.
Okay.
Yeah. And also for public folders, we have a website, keybase.pub, which exposes these public files. It's mainly for convenience because if you access keybase.pub, you have to trust that keybase.pub is not lying to you. But if you actually wanted the true verification, you would access it over KBFS. Right. And so if you access a folder with someone for the first time, you get something like this pop-up. Chris is one of the founders of Keybase. So you get a dialog box with a list of their social media identities, and it basically asks you, is this the person that you're talking to? And then you can verify that, this is his Twitter account, this is his GitHub, this is his Reddit. And then if that is the person, you click track, and then you'll be able to access that folder with him. Right. And so that is the UI of verification at Keybase. And behind the scenes, there's a lot of things going on. Your client is requesting that users approves from Keybase. It is like scraping all the tweets, all the posts on social media. It is verifying all the signatures. And then if that works, it downloads all the blocks. And then it makes sure all the blocks are signed and decrypts them. And then once that happens, it reconstructs the folder and presents them as plain files for you to read. So we're trying to make it simple enough that you can use the crypto without knowing anything about it.
So I've just gone to your akalin.keybase.pub.
Yeah.
And it's saying I'm getting 404. I'm
Right.
assuming that's because you have nothing in there.
I have nothing in there.
Also, if I put, for example, could I host stuff from here if I put a markdown file in there or whatever? Or?
Yeah, you can put whatever file in there. And I think if you...
So if I put like an index.html, for example, like it's saying, it will host a website? Or?
Yeah, you can host a website, a public website if you want.
Why not? Cool.
Okay. This part is freaking me out.
All right.
So you're saying you're monitoring tweets, posted, whatever, and then after making sure that you know these are me and mine and blah, 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 presenting them in what, my public folder As files?
Presenting them to you in your
To me?
operating system as files. I'm just saying that, like, if you can see the files, this is all done behind the scenes.
Why do you do this part?
To verify like that the person you're talking to is the person that you think it is, and then you're downloading their public keys, and then you're using those public keys to do the decryption and crypto and so on.
And the scraping of tweets and posts and profiles and stuff, is that continuously? Or is that once you set up the account?
Once you set up the account, like you post something on Twitter, and then we trap that particular post.
That
That's
tweet,
the
yeah.
only thing that we scrape.
And then the scraping stops? Or will you keep monitoring all the tweets and the posts? And because then it sounds like a security leak.
But it checks the tweet ID, for example.
Yeah.
If you delete that tweet, it
Yeah.
will go, you're no longer verified.
Okay. Yeah.
But
But it's only that single tweet, right?
right. I mean, we scrape the tweets ourselves for like our server to display on the Keybase website. Well, your client is the one that's doing the scraping because your client is the one that has to do the verification. So your client is like using the Twitter API to download like a particular tweet, and then checking that that tweet matches the signature and so on.
Okay, so I think I have it, but, but this hurts. So this is me authenticating myself to Keybase, or this is
No, you're already. I'm assuming that you're already authenticated with Keybase.
Okay.
This is your client authenticating the person whose folder you're accessing and getting their keys and then using that to decrypt the folder.
You think it would make sense to kind of do a whiteboard of that shortly, just to show what is the process?
Sure.
yeah, I
Makes
guess
sense. I don't know.
That could be hard to draw.
What?
That could be complicated to draw.
It is a bit hard to draw, but a previous slide.
I'm.
You're lost?
Go back a slide. Okay, so I'm going to access. So this person is shared. Is this a public folder I'm accessing?
This one in particular, yes, but it can also be for a private folder.
Okay, so
And you'll see the same information if you look at his Keybase page on the web. It just shows which accounts he's authenticated.
So again, what am I doing? What is the purpose of this? Taking some of my tweets and putting them as files. This is to authenticate me, or to? What? I don't understand why.
It's scraping. Your client is getting Chris's tweets.
Chris's tweets.
Yes, and so Chris's like what the particular tweet that is tied to his Keybase account.
Okay.
And then using that to verify that the same person controls that Twitter account and the Keybase account.
And how do I know, or is this something?
How do you know?
I mean, what's the purpose of putting them as files on my?
You don't.
You're not putting anything as files, I think. I think it's happening on the Keybase servers, actually. So the Keybase server is looking at Chris's timeline. It's looking for the tweet where he's validating his identity.
So he's looked at a particular tweet that he's made.
Just to make sure that it's him.
And he's validated, yes, that tweet was mine.
That tweet was Chris's.
That's Chris did that.
Yeah,
And
yeah.
like one time.
Yeah.
And then now what's happening? You're,
Right. Like after all that validation
yeah.
happens.
So that's why he's got all these accounts
Yeah.
that are validated.
Right.
Right.
And so tied to the Keybase account is also a public key, probably the same one that's used to sign all those social media accounts.
Okay.
And once you have someone's public key, then you can do crypto with that, right?
Right.
You can send them messages and so on. Or you can verify that the files that are in that folder are actually signed by him.
The files are all the payload of the things that you want to transfer with this person. The rest of the process is identifying that these files actually came from that person and haven't been
Maybe it's got a little deep. I mean, I understand the process. I was trying to figure out the whole like scraping tweets and.
So that's how you're verifying that it is who they claim to be.
Right.
And the cool thing is that this stuff all just happens automatically, and you don't have to deal with it. And that's kind of that is right there the cool thing about this all, is that it all happens nicely, transparently, and you can, well, if you trust this guy and his friends who are doing this, then you can kind of trust that that file that you're looking at really is what this real person uploaded. Because I've been validated now for a while. You know, you can go and revalidate me manually if you really want to, or you can just hit the, Keybase for sfosket, and you can rest assured that whatever I put in my public folder or whatever I put in a private folder for me and you really did come from me. It didn't come from somebody else or somebody who's like hijacked my Twitter account or something like that.
So in other words, it's security by lack of obscurity.
Yeah, it's not obscure at all.
Nice.
I guess so.
I need a microphone.
Don't drop anything.
Is that clearer for you?
Yeah, I think we just dipped down into the weeds there, and I was confusing, like implementation. The title did say behind the scenes, and I'm still in front of the curtain trying to figure out what the show is, and you're showing me the props. Okay.
I see.
All right.
Right, yeah. So the main idea is the client does all this in the background, all the verification, and all you see is either, if all the verification succeeds, a bunch of files, and if anything fails, then you don't see anything.
I guess part of it is that I've just lived in this world where, like is this? I'm sure the answer is yes. This is a real problem of people impersonating other people and sending emails that they didn't really send, sending tweets that they didn't really send, sending files that they didn't really send. That's not a problem in my world.
Yeah, and I can see that, because like if you're just reading my tweets, if somebody else says that Keybase is the cat's ass, well, you could say, well, Stephen I don't care if he said that.
I would probably text you and go, what the? Why did you just tweet that?
But for example, one thing you can do is you can validate a Bitcoin account.
Yeah, well, okay.
That's kind of important to know that I'm the guy who owns this Bitcoin account and nobody gave you the wrong number. Or as you're showing here with Keybase File System, you can validate a file transfer. So if I needed to send you like, oh, hey, Curtis, I want to give you my credit card number.
Right.
And I want to make sure that only you can see it. And you want to make sure that I'm the only one who sent it. We can both trust that this transfer is correct and this data is correct and it's not public.
Okay.
Right.
So yeah, you're right. There's a lot of things that you don't need to
It's just validate. There was a lot of emphasis, there seems to be a lot of emphasis on verifying the sender, that even, it seemed like even, I guess there's equal emphasis on verifying the sender and the receiver.
Yeah.
But I guess I just haven't, like in the case, like in the example you gave, so you gave me your wrong credit card number, I'd be fine, as long as it works, I don't care.
Well, somebody cares.
Yeah, somebody cares.
But yeah, there's exactly the same process as validating everyone all the time for every transaction, whether it's the sender or the receiver.
And how do you know? So you've verified me the one time. Mm-hmm. Now some time has passed. Mm-hmm. How do you know I'm still me?
Right. Well, I think Stephen brought up this idea of following, of people validating each other and then saying that, hey, I validated this person at this time. And then that's also a signed statement on Keybase. So that adds some trust to this, because if you see that someone has been validated by a bunch of people and all the validations, all the verifications still go through, you know that nothing has changed since then.
Yeah, I guess I'd have to see it in practice. Right now, it's all theory, so.
Right.
It won't take you that long to sign up.
Yeah, thanks.
I just sent you an invite.
Thank you very much.
You're welcome.
Right. I mean, the time element is, there's also like, let me think about this a bit. You're asking, like, your client scrapes the tweet now, and that tweet was made like a year ago. Right. How do you know that that's still valid?
No. a year ago you
Yeah.
scraped a tweet, and a year ago you validated Stephen, right? Now a year has passed,
Yeah.
and I'm interacting with some entity who claims to be Stephen. How do I know that's still Stephen?
Right. But your client is downloading the tweet now.
Oh, my client is downloading. My client, okay, this is the, so, but my client's not downloading the tweet from a year ago, right? He's downloading some recent tweet, right?
No, he's downloading
It's that
It's
tweet.
always
one particular
the
tweet.
same tweet.
Yeah.
The tweet lives forever.
Yeah.
Right, right.
The
Yeah, we know
tweet-
some people
yeah.
that know that.
So the tweet basically is the proof that it is you. So if you delete it,
No, but,
then the
but
valid.
that's only proof that that was me then.
Yeah.
But if it's not you, then you can revoke it. You can revoke that tweet from your
No,
Keybase.
but it was me. That was me that tweeted that a year ago, but now,
Curtis, who else would it be on Twitter on your account?
Well, no, I see where Curtis is
What if
going with
they
this.
change
Yeah.
their Twitter handles? Because people do that and forget to update this. Yes, somebody has a company name.
well,
in
that would
there
probably
and
get
one works
happen in
for that
Keybase.
company.
No, I'm more like between a year ago, my Twitter account has been hijacked, right? And I don't know. I don't know my Twitter account has been hijacked. You could still get my old tweet. Everything looks fine, but it's not me anymore. That's what I'm trying to understand.
Is this going back to abandonware?
It'd be more abandoned account,
Twitch.
And I think that's where the multiple verification sources become important. Because if Stephen gets his Twitter account hijacked, chances are he hasn't also gotten all of his accounts hijacked, unless he's been.
But at that point,
He's smart enough not to use the same password for everything.
Actually, no, I'm not. My password is just password.
But
You don't even capitalize the P at least? to
He
make it
uses
a little
dollar
more-
signs for the S, so it's totally
Yeah.
fine.
to answer your question, someone would have to hijack your Twitter account and your private key in order to be able to do anything.
To impersonate as you.
It doesn't matter what's happening with his Twitter profile anymore because the key is still the same key that it was a year ago.
Right.
So if somebody's tweeting dumb stuff from Steven's account, which we might not know whether that's Steven or a new guy,
Yeah, that's not a way to verify Stephen.
but let's assume it's not Steven.
Okay.
It doesn't matter because the key that you're using is still the same key that Steven authenticated with a year ago.
Right.
Okay.
So if someone
That's-
hijacks your Twitter account
So,
and doesn't do anything, then they can't read anything.
so
But
unless he deletes
if he deletes the Twitter account,
sexist, unless he or she
Yeah.
deletes the key, the validated tweet,
right.
then everything will still validate, and I'm verifying that he is who he says he is.
No, if he deletes the tweet, then like
That's what I'm saying. Then there'll be a problem,
Yeah.
right?
Right, but as long as it's there.
If
But
he
why,
tries-
why would they delete the tweet, right?
right, or if they try to
Like maybe they were trying to hack his Keybase account.
Right.
That wouldn't, he couldn't work, that would mess it up.
yeah,
Oh.
right. Someone would have to compromise
All of the accounts
all of the accounts or
and have his public key,
private key.
private key. Oh,
And you can make that easier for them by just having the same username and password on all your social media accounts.
yeah.
So if that entity who wasn't
No one
Stephen,
would ever do that, so.
so if that entity who wasn't Stephen, you were trying to send something to them securely, thinking they were, you'd encrypt it with Stephen's public key, but the recipient, not Stephen, wouldn't be able to decrypt it because they wouldn't have Stephen's private key.
Right.
So
And
there'd be
if-
the waste of time of sending it to the wrong place, but your data would still stay secure.
And if they impersonated Stephen via, let's say, sfosket2, right, they wouldn't be authenticated. They would get a different private key
Right.
Exactly.
and wouldn't be able to.
Yeah. And wouldn't be able to be tied to his Keybase account. And even
Really, Stephen, you made the comment that it's like Dropbox. It's really, it's like the sharing aspect of Dropbox. Dropbox is more than just that, but it's mainly just the sharing aspect of Dropbox.
Well, it's also the other aspects as well, because if you have multiple devices, like I've got,
For up to 10,
I don't want to,
up to 10 gigabyte,
yeah, exactly.
For now.
For now. I mean, it's still a kind of beta product, but I mean, I don't want to give it away, but I got some good stuff in my private Keybase account. And the cool thing is, it's on my Linux machines, all the different Linux machines, and it's on my Mac.
Right.
And since my password is password, you all can find out exactly what the stuff is. But
So if they could monetize it and make it be bigger than 10 gigabyte, then it would be very much like Dropbox.
yeah, because it'll share. You can also use your private to share things between,
Your keys.
like your authorized keys for SSH,
Right.
for example.
Yeah, we're trying to make it easier to use than Dropbox in that if you only know someone's particular social media account, then you can share stuff with them. You don't have to know their Dropbox email or whatever.
Right.
And also, I'll go over this later, but we're a bit different than Dropbox in that we don't sync files, but it's actually a network file system.
Right.
So you don't have to download the whole 10 gigabytes on your hard drive or whatever. Right.
They're not tiered storage.
Okay, so now I can talk about the tech behind KBFS.
Oh, that was the high-level salesy part.
Yeah. So, as I said before, it's a distributed file system with end-to-end encryption and a global namespace. Distributed means you can access it from any device. File system means that there's no sync model. As I said, unlike Dropbox, we don't have to sync all your files down. It's not like a folder that is synced with a remote folder. It is a true network file system.
Do you ever see that changing?
What?
Do you ever see that changing?
No, I see perhaps it converging in the sense that if you have a real network file system, you add prefetching, you add caching, and then you effectively download all the stuff that you're using. So it's it is similar to syncing everything up front and then working with that locally.
Well, it's just, I've been working for a new company recently, and they live in Google Apps, right? And I historically lived in Dropbox land, right? And now I get on a plane, and I'm dead.
Right.
Right? So it's not the same in that aspect, right? We're not always connected.
Yeah, we would have to implement a way for you to browse your files while offline. Yes.
Right.
So there are pros and cons to both approaches. So end-to-end encryption means that only the people that are intended to read and write a piece of data can do so. Dropbox can read your Dropbox files. Google Drive can read your Google Drive files. And they have been known to do that. They have been known to scan files looking for stuff. So,
how do you authenticate me on the device itself to read a file?
your device has a private key. And if you have that private key, then you can decrypt anything that's encrypted with the public key. And so that's how the possession of that private key is.
So this laptop is on right now. Mm-hmm. I don't have a automatically lock the screen feature. It's essentially authenticated this device. It's authenticated me, right? Mm-hmm. So if I walk away, someone accesses my laptop, they're going to access my private data.
Yes.
Okay.
The technical way of saying it is that our threat model doesn't include, it assumes that your devices are secure. If you lose a device, then we have a way for you to revoke that device. But if you get up and walk away and you leave your laptop untouched, then someone else can look at your files.
Well, like I use a password manager, right?
Yeah.
It assumes I'm me for a period of time. Mm-hmm. And then after that period of time, I have to re-enter my master password for that system to work. So you don't really have anything like that, sounds like.
You have to log into Keybase, but I mean, when you first set it up, but I don't think, we don't have anything like
once you're logged in, you're logged in.
Yeah.
Okay.
That's just kind of the nature of that security scheme, though, is like, if you have the private key, then obviously you're supposed to be able to decrypt anything that was encrypted with the public key. So it's kind of on you to protect your private key.
We store the private key in, like on OS X, we store it in the keychain. But it still doesn't solve the problem because if your laptop is unlocked, it's already cached in memory. So don't leave your laptop unlocked.
Right.
Yeah.
Well, one of the points of discussion was making this more accessible to, the people out there that use their password as password. And those people aren't doing that, right?
Right.
They don't even have a freaking passcode on their phone, right? So that's why I'm asking that question.
Yeah. It is a problem.
Huh?
I was going to say they're probably not the kind of people that are actually concerned about encrypting stuff, right? Either, though, right?
What?
If you've not got a pin on your phone and you don't lock your laptop, you probably don't care about encrypting anything, right?
Yeah, I guess.
Yeah.
I'm not saying that's a good thing,
Yeah.
but
Well, but if I want to share something with that person
yeah,
and only that person, I can't really. I'm still trusting that person.
yeah,
Right.
Trusting that person and their own security practices, which
Right.
yeah,
generally suck.
yeah.
You have to share files with them with that in mind.
Yeah.
You have to trust them. Like if any of their devices are compromised, then we can't really do anything about it. And even like,
His credit card number is sitting here on my open screen
yeah,
for anybody to look at.
Yeah, I mean, but like I probably wouldn't.
Is it right now? Thanks, Ben. Can I just write it on the whiteboard? Yeah.
I probably wouldn't email my grandma or my mother my credit card numbers because I don't trust her to keep her email secure, right? Hope she's not watching. But it's just you've got to be wary of these things, as you said.
I think it probably boils down to is the information I want to share secure, and if the person I need to share it with is security conscious.
Yeah.
Because you have some people with whom it's absolutely useless to ever think they're gonna care about that. So you need to educate the people to if they are sensitive to the message, and then, well, you can communicate encrypted with them. But if they're not receptive to that, then nothing much of help here.
right.
I just want to jump in here real quick because I'm a huge fan of the security aspects behind the file system. Curtis, you're absolutely right. What we're trying to do is we're trying to take a concept that we've had in security for 20 years at this point, and we're trying to make it more accessible
That
to
concept
people.
being private and public key.
Yeah, private and public keys, because it's a whole lot better than trying to distribute symmetrical keys, because as soon as you lose one of those, everything is gone. The problem is that we hit a technology limitation. So how does your password manager know that you're not you anymore? Does it have a magical capability for you for it to detect that you've exited a boundary around your laptop and it should automatically lock?
The only thing it has is time.
And that's the problem, is what looks like a novel solution is actually something really simple. And the problem is we have to have a technology foundation in order for that to work. So the newest MacBooks can actually detect how close you are with the right dongle attached to your wrist and automatically choose to do things based on a specific thing other than time now. So eventually down the road, with Keybase having hooked into all those APIs, maybe it is capable of saying that if you're carrying your phone or your watch or something that identifies you, who you are, that when you step outside of this boundary, that it will automatically slam all the doors shut so that nobody can impersonate you. But until we hit that technology, the best that we can hope for is to educate people that don't leave things around. I mean, how many people in here have ever worked for an enterprise that had a policy that you had to lock your laptop when you walked away from it? How many people in here have ever found somebody's unlocked laptop and chosen to embarrass somebody by doing something on it that you shouldn't have? It happened to me at Networking Field Day too. Kurt Bales, hi Kurt, decided to send out a couple of really random tweets because I walked away and my laptop was open. Guess what? Ever since then, my laptop has stayed closed if I'm more than a foot away from it. And that's why, is because I'm training myself to use better security practices.
Have you invited him back since then, Tom?
We did.
Oh, okay.
Yeah. Yeah, but not to one I went to. So, yeah. Anyway, sorry.
No, yeah, I just wanted to add to that in that desktop and laptop computers have a long history, and you have a history where security wasn't as much of a concern back then.
Right.
And some of that legacy is with us to this day. But with newer devices like phones and so on that are becoming more prevalent, Apple is making it really easy for people to set up Touch ID, to set up passcodes, even though, as you said, some people still don't have PIN codes on their phone.
Right.
But the trend is towards better security.
Yeah.
And ideally,
And I don't want to make it sound like I'm crapping on your thing because of one issue. I just trying to understand it.
It's a valid concern.
Yeah.
All right. So, yes, global namespace means that every file on KBFS has a unique global path that you can use to access it. I guess this is similar to other network file systems like AFS, if you know about that. This is, if you're following along on the slides, I have a link to a document which explains all of this in gory detail. Right, so as for the clients, they're based on Fuse on Linux and Fuse for Mac OS on Mac. And on Windows, we use something called Dopen, which is the equivalent to Fuse for Windows. And the client talks to the Keybase service for identity verification, like I mentioned before. And talks to block servers, block servers are basically dumb content address data stores. And the clients talk to metadata servers, which are a linear record, which store linear records of changes to a TLF, which is our term for a top-level folder, which is like something like Keybase private Akalin, comma username, comma your name. We think of that as a single top-level folder.
And files, it's not, the files are stored on my regular file system, right? It's not a separate volume.
No, it's a separate volume in the sense that it's a network file system, like a Samba mount or something else.
But when you download the files, when I'm accessing the files on my local machine.
Yeah.
So let me rephrase. Yeah, so you're saying it's a separate volume in that, like, if I do a DF, I'm going to see it listed as a network volume. Mm-hmm. Okay.
Yeah.
All right.
And then, I mean, they cache the stuff, the data that you download in memory and so on.
Yeah.
But like, you can wipe out all those caches and still be able to access your file. It'll just download it over the network. Right. So KBFS blocks. A file is split up into blocks of roughly equal size, and they all have an ID. We encode them, we encrypt them, and then we take the hash of that, and that's a block ID. And directories are just lists of names and block IDs. And so a top-level folder basically forms a Merkle tree. Do all of you know? Are all of you familiar with? Okay, so I will explain that with this diagram here. So you have the root node up here. As you can see, it has a list of children it has a directory and a file, and each child maps to a block ID. In this case, they're like small numbers, but in production, they're like long SHA hashes, SHA-256 hashes. And so when you go down to the lowest layer with the files, the individual blocks have an ID associated with them. And the directory has a map from name to block ID, and it itself has an ID. And so at the very top, you have a directory. You have the root directory with a list of block IDs. And so the idea is that you can verify the file that you're accessing piecewise, in that when you traverse the path, you're doing a verification check at every step. If the block ID doesn't match, then either the file is corrupted or maliciously change. And so when you access the file at the very bottom, you know that everything is valid up to that point. Any questions? I don't know if I
About
explained that.
700. I'm just going to go with that. I don't need to know what Merkle is right now.
Okay.
We're good.
Right.
I'm not speaking for anybody else, but
the idea here is that from the client's
it's a
point of
way
view,
of verifying the files are really the files. And
right?
Yeah.
Yeah. Yeah. The idea here is that the client can see a directory structure, like a file system structure with inodes and so on. And on the server side, all the server sees is a list of block IDs and a map from the block ID to an encrypted blob. And that's all the block server knows. And the metadata, which is like the data about the top level folder, most obviously is the root block ID, so the ID of the root block, a list of changes since the previous revision, and crypto stuff, which I'll go over in a future slide. And it also has a public component, which is basically the hash of a metadata object, a revision number, and a pointer to the previous metadata object. So it forms a list of sequential revisions. And as a side, this will let us in the future implement a way for you to look up old versions of files, which is also a nice benefit. So this is what the metadata looks like for a folder. You have a list of revisions. Like, for example, the first revision, you have a root block ID over here, which is presumably empty. You have a set of keys, which I'll go over in a bit, and a signature saying that my particular device was the one that made that revision. And so someone reading that metadata object would be able to know who did what in that folder. And then for the second revision, like if I have a folder with Chris, he made a directory, it's all recorded. You have a new root node, you have a list of changes, and then you have a signature by Chris, and then a pointer pointing to the previous revision. And then for the third revision, let's say I lost my device, I have to revoke it and sign a new one. We have a key rotation, which I'll talk about in a bit, and nothing else has changed. And if you're familiar with Git, this is very similar to how Git works. You sort of have a linear record of changes, and each change has a pointer to a root node, and then if you follow that root node, you have a list of files. All right. Okay, so an overview of the crypto. A single top-level folder has generations of secret keys, and these keys are encrypted for all the participants using their public keys. So that's how we guarantee that only the people who are participating in the folder are able to read that. And we use, like, if we have the latest key for a top-level folder, we use that key to generate block keys. So each block has their own key. And right now we store the server half of that key with the encrypted block. But the idea is that like if you wanted to delete a block from say S3 or a CDN, you're not exactly sure when the block will actually be deleted. So in the future, we'll probably run our own key servers that stores the block keys. And when you want to delete a file, we just delete the key. And everyone else has the encrypted block, but they can't. No one can do anything with it because they don't have the key. Right. And all the gory details are in the crypto spec, which is linked down below. Right. And we actually, I think someone asked how can one be sure that Keybase isn't lying or changing the history? We integrate with the Bitcoin blockchain in that Keybase already has a Merkle tree of all the data in the Keybase repository, in the Keybase in the server, like a list of all the accounts, all the proofs, and so on. And we publish the hash of that every so often to the blockchain. And so we can also form Merkle trees from the set of the public and private TLFs and fold that into the Merkle tree of the main Merkle tree and publish that. So basically someone can look in the blockchain, which is the globally distributed data store, and verify that we're not leaving out data. And so if an attacker wanted to fool people into thinking that Keybase is serving up data that they're not, they would have to fork the Bitcoin blockchain. Right. And before I go on to the challenges that we face, are there any questions about that? You're good? Good.
Yeah,
That was a lot, I
I'm
think.
totally down.
Okay. I mean, if you want me to talk about some other stuff, I can also, okay, great.
No, this is great.
No, I had heard.
Do a very quick introduction on what blockchain is.
Blockchain, right. So a blockchain, I don't know that much about Bitcoin myself, but I know the basics. A blockchain is, it's a linear record of changes where each node has a hash, can be hashed, and then each node has the hash of the previous version. And what Bitcoin does on top of that is that there's I'm kind of mangle this because I'm not a Bitcoin expert, but
Me neither.
yeah, there's something called proof of work, which means that when you're mining Bitcoin stuff, you're solving these hard math problems, and then you can sign that proof of work into the blockchain to prove that you have done some work, and using that you can sort of build a consensus among everybody that's participating in the blockchain. Like anyone can look at your proof of work and prove that it is you who's done that work. And then from there,
So when you guys push your information to the blockchain, that again creates that kind of almost immutable record, right?
yeah, it's like an immutable record. And the idea with Bitcoin is that you use that immutable record to have a distributed ledger and not a centralized list of transactions. But you can also use it to record data that will never be changed, or immutable data. Like you can pay yourself like a fraction of a Bitcoin, and then that you can put whatever data you want in there. That's the idea. All right. Challenges. POSIX compliance. Basically, if you obey the POSIX spec as it's written, it just kills performance. I think, I guess you're all storage folks, you're probably familiar with this. But respecting the exclusive flag for a network file system, if you want one client to write to a file exclusively, you have to do a server round trip and make sure that no one else is writing to that file. If you do a file sync on a client, I think the spec says something like the sync has to return after the data has been written to the backing store, which is in this case a server. So if you do a sync, you have to that incurs a server round trip, so that kills performance if you have a lot of files. And so for file syncs, we just basically journal a list of operations locally and then sync that in the background. And another challenge is worst case performance, which in our case is when you have lots of little files. Because every file operation, you need to create a new metadata object. And every file operation, you have to create new directory blocks all the way up to the root. So if you're creating like 3 or 4 new blocks for every file create, for every file sync, for every rename, then that adds up to a lot of traffic. And I think we're probably going to implement some form of coalescing of file updates to avoid having to send so much traffic back and forth. Challenges, integration with the operating system. Only use on Linux as part of the kernel is like a first-class citizen. On OS X, or macOS as it is called now, very recently there was an update, macOS Sierra. It broke Fuse on macOS, so if you upgrade it to Sierra, KBFS will be broken for you. Yeah, right. We fixed that now, but I think the challenge is to, what do we do about that? I mean, do we have to go through this every year when Apple releases their product?
So in your latest application, you've added a function to add a phone device.
What?
You have added a function in your latest app to add phone devices.
To add phone devices?
Yeah, phones.
Yes, phones.
Yeah, we're planning that.
Yeah, you're planning that. So I was wondering if...
We really want that.
Yeah, we're working on it.
Okay.
I don't work on that part of Keybase myself, but we have some prototypes, but really nothing that we're able to show publicly yet.
You need beta testers. I got a group of people.
All right, yeah.
Alpha testers, for instance.
Right. And then there's similar problems on Windows with Dokkan, and because it's like a kernel driver, we've had problems with updated versions causing blue screens and so on. So we just have to like keep...
Doesn't sound like Windows at all.
Yeah, you have to keep on top of this. Another challenge is debugging. We cannot see into your folders by design, so if you have a problem, we rely on you to send us logs, and we rely on bug reports. Because if something is wrong, we can't even know that something is wrong. So I think once we scale beyond the tech-savvy people, we have to figure out a way to handle support requests from people who aren't really familiar with the command line.
Well, for what it's worth, I mean, a lot of programs still do require users to submit stuff.
Mm-hmm.
You know, I had a 1Password bug, and they needed me to click this and type that, and it worked. You know, it's okay. I'd also like to see a FreeBSD port, by the way.
Yeah.
Yeah.
I think I have to check, but I think the clients are basically reliant on. We use Go, the programming language, and I think we're reliant on ports of Go to other platforms. It probably is a BSD port, but we just don't package it ourselves. But it's not entirely out of the question. I don't know if there is a Fuse equivalent for FreeBSD though. There is?
I think so.
Okay.
But
yeah,
if not, there ought to be.
There ought to be,
I'm pretty sure there is. Yeah.
Yeah, I think there have been bugs floating around about people trying to get it to work on various.
For what it's worth, Dropbox doesn't work on FreeBSD either.
Okay, yeah. Various BSDs or even Linux on ARM or on like Raspberry Pis.
Yeah, that'd be useful too.
Mm-hmm. And that's basically it. If you want to sign up for Keybase, there's a invite code down below. We're still invite only. We don't want to grow too quickly, too fast. But yeah. And that's the Keybase team in the recent gathering. Any questions?
Is it perfectly clear to you, Curtis, now?
Absolutely.
Excellent. Solved.
Just clear as
The process seems simple. I was able to install the app and get signed up and get everything going while this presentation's been going.
Great. Good to hear.
So, you know, when you come out with the version for Android, I'll be ready to add that device as well.
Android, iOS, yes. We're working on it.
Yeah, and Atari ST, I'm really eager to get also an 8-bit Atari client.
Oh,
and, there's no networking, but if there was, I'd like to use Keybase.
So you guys have, what, about 10 million in funding? Is that right? I was just...
Yeah, 10 million from Andreessen Horowitz.
Yeah, how do you see this working out? You know, I was just reading online about this, and you know, they like the concept. They're behind it. It's got to be an unusual business model and an unusual exit strategy, if there is one.
Mm-hmm.
Yeah.
The founders know better than I about the exit strategy part, but there are various models we can do. We can charge for storage. That would be the most obvious one.
Yeah.
We're also working on other applications besides the file system. I think another one we're looking at is chat. So I think we're not focusing on our revenue model yet, but it's something that we have in mind. We keep in mind.
How is the data that's stored up there protected? And I don't mean encryption.
What do you mean?
Against deletion and fire and all those things that I care about.
Right. We use AWS mostly, so we're reliant on S3's data protection policy. I don't know exactly what guarantees they have.
Okay, just Google codebases.com and you'll see how excited I am about that.
All right. For what it's worth, we're not tied to AWS. We can do like some wallet files that we have. We can do replication on multiple services and so on.
Yeah. Can do and are doing are two very different things.
Right.
Yeah. So codespaces.com was a place to store your code, and one hack, and they stored everything in Amazon and S3. One hack, and
they were done.
They were held for ransom, and they told them to go pound sand, and the guy goes, "Well, F you," and he
went and deleted everything.
Deleted their company. And they actually had a revenue model. They were making money, and then just in a matter of seconds, everybody's data just disappeared. So I hate to see something like that happen to you guys.
Right. So we still have a disclaimer that the KBFS is still in alpha. Don't put anything in it that you wouldn't.
Sure. That works for a little while.
For a little while, yes.
Yeah.
I remember Gmail was in beta for a long time.
Yeah.
And I think they only took it out of beta once they had
Gmail is
tape backups.
5 years.
What?
I think it's been 4 years or 5 years in beta at least.
Yeah.
Gmail.
Yeah. And they were only willing to release it, to put it out of beta once they had tape backups. I don't have any inside knowledge of it. This is just rumors.
Yeah. No, that sounds about right. But
yeah.
I'd be happy to talk to you about that offline, and especially before you discover a revenue model and start charging people, and then losing all their, or before you do, and then it would be a shame for a negative event to publicly slam an otherwise good idea.
Yeah, I agree.
So be happy to chat with you about that.